Hey everyone, Aditya Shukla here, and this is my submission for Google Rapid Agent Hackathon or the Arize track, and I've built Iris. As we all know, the implementation and use cases for AI agents in healthcare is increasing every day. But when these agents hallucinate, for example, when they hallucinate a drug dose or miss a contradiction, there is no alarm that fires. Studies show that 91% of the clinicians have encountered it, and there are multiple downstream impacts that are faced when they encounter these hallucinations. There are no runtime safety layers, and nothing that fixes this automatically. That is Iris. The layer between your AI and your patients sits between clinical agents and their users. Every output is evaluated in real time across 7 different evaluators, grounded in RxNorm and OpenFDA knowledge bases, not just LLM judgments. You can read more about the architecture, the evaluators, the agents and MCPs used behind the scenes in the later point. And without further ado, let's go to the live dashboard. For the purpose of this demo, we'll be using a sample pre-built set of prompts and responses, which will perform poorly on the initial evaluators. We'll see how Arize MCP service detects those failures and runs the self-healing pipeline on these prompts, and how Mutation Engine computes the text grad style gradients to improve those prompts. So let's trigger these 4 selected sample prompts initially. Let's run the simulation. For this 4-minute demo video, I will have to leave out the technical details, but all the technical end-to-end implementation is mentioned in this workflow. You can pause and look at it. As you can see, the logs have started to show up. Now that all the 4 prompts have ran, you can see the activity log here for each, and on the live traces tab, we can see each of those 4 prompts traces. Clicking on each gives us an evaluator level summary. For example, for this particular prompt, 4 evaluators have failed, 1 has given warning, and 1 has given a successful pass. You can also see the thinking steps for each output, and at the top here, we can see the evaluator level heat map. So as we expect, all the prompts are failing. That's why it's showing critical for all the 3 prompts and 1 prompt. If you look at the traces in Arize, you can see evaluator tags for all these 4 prompts, and let's look at one particular one. These are all the 7 evaluators that we have: factual, hallucination, drug dosage boundary, attribution, context gap, and each of these evaluators gives us an output of a score, passed, flag, severity, and the evaluator itself. If we go back, we can see a chain of pattern detector. Now, if you look at the dashboard again, there are 4 prompts that all of them failed, and initially we have set the threshold to 2 failures. So once this threshold is met, it automatically triggers the scanner to detect the patterns. It triggered the MCP server on Phoenix to get the spans. So it looked at the previous 30 spans, and it found one cluster with 100% failure rate for this particular category, drug dosage. So once this cluster was detected, it automatically triggered the healing pipeline. So that healing pipeline used TextGrad like Mutation Engine, and that produced a candidate prompt, the new prompt, which in turn was passed through the 7 evaluators. And based on the evaluation, it produced a 2.5% of improvement compared to the previous prompt. So that automatically prompt got deployed to Arize. So this was the old hash, and the new hash can be found as a production prompt. So let's go back to the prompts in Phoenix, and if we look at the latest version, that version hash should match. So yeah, this is the version that got deployed automatically. Let's run the same prompts but using the live generation option. So what this does is, instead of using the previous prompts, it fetches the latest prompt from Phoenix and runs the evaluators through them. So this might take a while. So let's run this and look at the logs. The candidate prompt that was pushed to Arize can also be seen on the UI in the history. So this is a prompt with 2.5% improvement. This is the before prompt. This is the after prompt that was pushed, and using which we triggered the same 4 scenarios again. And as you can see in this agent improvement panel, initially we had 4, all of them failed, 4 scenarios, and then using the new prompt, it resulted in 25% improvement with 1 of the scenario passing. Since the rest 3 of them all failed again, it crosses the threshold of 2 again. So that triggered the MCP server again to improve the prompt more. So the MCP server looked at the more 30 spans, that triggered healing pipeline, that produced another prompt. So that in turn created a new prompt with 4.8% improvement. So this was the prompt before, this was the prompt after. Now if we were to trigger the run again using the new prompt, it will result in even more improvement, from 25% at least to another 50%. So this is how leveraging Arize MCP servers along with Google ADK agents allows us to have a self-healing observability layer for any agent deployed in clinical settings.